My name is SumitBarnwal and currently I am intern at Emertxe Information Technology. I am doing this internship based on embedded system and during this internship I am build a project based on MPLab XIDE simulating on software PicSimLab. I work on the project microwave oven simulation. The topic that I learned during internship: introduction to C language, array, pointer, string, function, and loops. Introduction to embedded system, microcontroller, MPLab XID for writing the code, X8 compiler for compile the code, and PicSimLab for simulation the microwave oven. And introduction to various peripheral of PIC16F877A. The requirements of project are MPLab XIDE, X8 compiler, PicSimLab, PIC16F877A. So coming to what is embedded system? Now embedded system is a combination of both hardware and software which perform a specific function. Characteristics of embedded systems: dedicated functionality and domain specific, reactive and real time, small size. Some example of embedded systems are microwave oven, washing machine, digital cameras, etc. So in this slide, we will see the current sourcing and current sinking circuit. The first one is current sourcing circuit. When the load is connected to the device so that the device supplies current to the load, then the configuration is said to be current sourcing. An example is the series resistor and LED connected between microcontroller pin and ground. When the microcontroller pin is switched high, then the microcontroller will source current to the load. In this configuration, the logic 1 will supply the power to the load and logic 0 switch power to the load off. This one is the current sinking circuit when the load is connected to the device so that the current flows from the power supply through this load and into the device. Then the configuration is said to be current sinking. An example of current sinking: when a series resistor and an LED is connected between power and microcontroller pin. When the microcontroller pin is switched high, then the current to the load is switched off. When the microcontroller is switched to pin low, current flow through the load. This slide is about the pull up and pull down resistor. First one is the pull up resistor. Pull up resistors are resistors which are used to ensure that the wire is pulled to a high logical level in the absence of an input signal, while pull down resistors work in the same manner resistor, except that they pull the pin to a logical low value. This is the matrix keypad. This is a keypad in which number of tactile switches are connected in a row and column concept. This is used when more number of inputs are required. They are most commonly used in calculator, DigiLocker, etc. The rows are configured as output by giving logic 0. The columns are configured as inputs by giving logic 1. This is the CLCD character liquid crystal display. In PicSimLab, there are two types of display. As we need more number of rows in our project, so here we are using 16 cross 4 display and 4-bit mode because our tactile switch is also connected to SIM port, which is port D, in which matrix keypad is connected. Interrupt. We can see interrupt is divided between hardware and software, and hardware is also divided non-maskable and maskable, and maskable is divided between external and internal. An interrupt is a communication process set up in a microprocessor or microcontroller in which an external or internal device requests the processing MPU to stop the processing. The MPU acknowledges this request, attend to the request, goes back to the processing where it was interrupted. ISR. ISR, interrupt service routine. which examines an interrupt and determines how to handle it and execute the handling and then return it to a logical return value. Timers. The timer is nothing but a simple binary counter that can be configured to count clock pulses, internal or external. These are used to measure the time or generate an accurate time delay. In PicSimLab for the board PIC16F877A, we have three timers: timer 0, timer 1, and timer 2. For our project microwave oven, we are using timer 2. Microwave oven. Microwave oven is a kitchen appliance that uses electromagnetic radiation in the microwave frequency range to heat and cook food. Modes of microwave oven are microwave mode, grill mode, convection mode. Also, we are using start mode to start the microwave oven. This is the architecture of PicSimLab PIC16F877A. Here we have GPIO, that is general purpose input output for connecting external components, then I2C, then LM35 temperature sensor, then analog to digital converter, LEDs, buzzer, digital keypads, also matrix keypad, CLCD, all these are connected to the PIC16F877A processor. This is PIC16F877A microcontroller board. Here, these are 16 LEDs. These are ports. This is the PIC16F877A IC. This is the fan. This is buzzer. And this is CLCD display. Thank you. Now my
PicSimLab
friend explain about the
Simulator.
project microwave oven and PicSimLab.
It is looking like that. First, I show you the code of this process. So I am opening that MPLab X IDE. Here I wrote all code. This is the matrix header file, and this is the CLCD header file, and timer main file it is, and this is my main.h and main.c file. Here main.c file I wrote all condition and all loops, and I include all libraries in this main.c. Here I include only main.h, and inside that main.h I I include um, all header file. Now I am going to show the output on PicSimLab simulator. This is my PicSimLab simulator. You can see here is many boards where I choose a pick generic board. Inside pick generic board I am selecting PIC16F877A board. This is my PicSimLab simulator, and this is my PIC16F877A microcontroller. And here it is the IC. Now I am going to start it by resetting my microcontroller. Again I am starting. When I reset it, it start from beginning. See first it welcoming power on microwave oven. Now here is the four mode: micro mode, grill mode, convection mode, and start mode. Inside micro mode, we set our microcontroller like that. It will take the time, and it will cook the food. So I am pressing 1 here for selecting microwave oven. So here it is showing it is taking 900 watt. Mm, Now I am giving the input as time. First I am giving 32 second and 12 minutes, and after entering you can see our fan is started, and you can also observe that a relay is on. Means whatever devices connected with this relay, it will become on, and our timer is also reducing second by second by the help of timer. Here there is three option: start, pause, and stop. If I press pause, you can see it uh, it stop at that condition only, and if I will start it, it will again start at that point only. And during start time, during running time, if I press key number 4, you can see it increase by 30 second. If I want more time to cook our food, we can increase by pressing this. Now this is the 6 number key. When I press 6 number key, it will comes out and show the menu. Micro mode and grill mode are same. In grill mode, directly we configure the time. So now I am showing the grill mode. When I pressing 2, it select the grill mode, and it shows the timer. Now I am set the small time 25 second only, and if I press the star button, you can see it will clear. And now I am giving 25 second only to show the output. Now when I press the hash key, it will start, and you can see mm, our relay will come on, and our fan is showing a circuit is on, and it is a decreasing time. Only 10 second is remain. uh, Grill mode and micro mode is same. When it completed, you can hear the sound of buzzer also, and show the time up. Now I am going toward our third condition, convection mode. Inside that convection mode, first we have to give the temperature, at what temperature I want to cook. So I will give 125 degrees Celsius. Now I press the hash for enter. You can see it is starting preheating. After preheating, it will go to the timer set mode, and we set the time, how much time I want to cook, and it will start. Preheating time become over, and it comes to time set mode. Here I also give small uh, time only 40 second, and I start. You can see fan start running, and like that our relay will on, and the heat circuit, means heater circuit will turn on by this relay. After time up, it give a buzzer sound. And at last, the fourth option is uh, start mode. If I want to heat something, or want to uh, light hot something, then I select that start mode. So when I press 4 key, it directly set to 30-second mode, and start directly timer. And if I want more time, then again I press 4 in running time only, it increase by 30 second. You can see we can pause also, and again we can start. And if I want our food is completely cooked, so we can stop it directly by pressing 6 number pin. So I think you understand that working of this microwave oven controller simulation. So I thank to Emertxe to give that info, that knowledge to us. This